Thank you so much. I'm just going to quickly share my screen. Okay, so I'm going to talk about emerging safety considerations, specifically around autonomous aircraft. I'm choosing to talk about unmanned aircraft as a main example throughout this presentation because I wanted to highlight the depth and complexity of safety considerations using a practical case study, as opposed to just going through the broader presentation on robotics in general. So I wanted to start by just going over some basic terminology that's often misused or used interchangeably, particularly in the aviation space. I'll start with automation and autonomy. Automation and autonomy are constantly used interchangeably, but they're actually not the same thing, and they're quite different. Automation refers to the execution of a predefined task performed without human assistance. It's deterministic, the outcome is known. Whereas with autonomy, it refers to performance under significant uncertainties within an environment. It's non-deterministic, and it requires decision-making without human assistance that may result in a range of possible outcomes. So bringing this back to the contents of unmanned aircraft, we hear the word RPAS thrown around quite a bit. It's remotely piloted aircraft systems. Technically, this is neither autonomy nor automation. Really, it refers to an aerial vehicle being controlled in real time by a human. For aviation, autonomy and automation come into play when we start looking at the embedded systems of these vehicles. And these are referred to as the unmanned aircraft systems, or UAS. The vehicles themselves are referred to as unmanned aerial vehicles, or UAVs. And the vehicles are a component of the unmanned aircraft system. And then finally, we have drones. Drones is a term that's used extensively, and it seems to encompass so many different terminologies. We constantly see statements like drone warfare or drone delivery system, but we never see things like unmanned aircraft system warfare or unmanned aerial vehicle delivery system. I think it just doesn't roll off the tongue as nicely. But the term drone does seem to have become a general term for these systems and vehicles that most people can identify with. And it's a term that I'll use throughout this presentation as well. I want to briefly touch on levels of autonomy for unmanned aircraft. The automotive industry has defined levels of automation for automated driving. They're referred to as the SAE levels of automation. But at this stage, the aviation industry doesn't really have an equivalent. So why is this important? Why do we need to clearly identify levels of autonomy for drones? The level of autonomy is a reflection of the level of human intervention and decision-making in the system. So the more autonomous the system is, the less human intervention and decision-making that's required. It's important to know if a drone is being remotely piloted or if it's completely autonomous and non-deterministic. We need to know who the decision makers are for that vehicle. We constantly talk about things like visual line of sight or beyond visual line of sight, but what does that actually mean in the context of real operations? Are we allowing remotely piloted aircraft to operate in the same space as completely autonomous aircraft? The safety considerations of these systems will be heavily influenced by how autonomous they are. So this lends itself to the question of how much autonomy do we actually allow these systems? We have to consider what the potential issues will be when low altitude airspace is densely occupied with unmanned aircraft at varying levels of autonomy. Is it safe to have varying levels of autonomy in unmanned aircraft? Is increasing the human component actually safer? I know that having a human in the loop is the norm for our society, but is it actually safer to have a human in the loop for autonomous systems? This is a really important consideration when looking at the commercial operations of these systems. Currently, companies like Uber Air that are proposing air taxis and other companies proposing drone delivery services are going forward with the intention of flying in low altitude airspace. The International Civil Aviation Organization, or ICAO, has implemented airspace classifications that are used in most parts of the world. We use them here in Australia. Class A provides the highest level of service from air traffic controllers, and then that level of service sort of decreases with each class. And once you get air traffic controllers in the mix, you're increasing the human decision-making components into the system. Interestingly, The different classes don't have a minimum altitude boundary. The airspace classes are essentially applied from the ground up, which means that technically aircraft flying in low altitude airspace within these classes would have to adhere to the rules of the airspace that they're flying within. But currently ICAO and the Australian regulator CASA don't reference airspace classes with respect to RPAS. There are plenty of standards around maximum flying altitude, limitations around where RPAS can be flown, etc. But there are no standards around RPAS complying with the operating procedures in respective airspace classes. I understand that at the stage that RPAS is at now, this may seem like a semantic problem, but what happens when we start having air taxis and autonomous delivery services? Theoretically, if these systems are fully autonomous and non-deterministic systems, they don't have a need for air traffic controllers. So those airspace classes are redundant. We could potentially put a lower limit on these airspace classes that excludes low altitude airspace, but there are manned flights that fly within those altitudes. For example, helicopter emergency medical services, which is a pretty critical service. So applying a lower limit to the airspace classes would exclude manned aircraft from low altitude airspace, which I don't think is an ideal solution. Manned aviation, it's a system that's built on human interaction and communication. It's a multifaceted system that's built around these human-based roles that have been around for decades. But unmanned aviation is just a whole new ballgame because these external human roles no longer need to be in the picture. Assuming that we're dealing with a fully autonomous system, there are no pilots and there are no air traffic controllers. So we need to find a balance between these two services. And finding this balance starts by recognizing that the needs of unmanned aviation are very different, and therefore they don't necessarily need to be squeezed into the existing framework. I wanted to build on the points around the existing manned civil aviation framework just a little bit more. ICAO Annex 10 outlines rules of the air. It's an international standard that covers things from flight plans and air traffic control services to emergency signals and general operating rules. The differing operational requirements of unmanned aircraft will require a review of these standards if unmanned aircraft are going to be required to adhere to those standards. The main objective of any air traffic management system is to achieve a safe and efficient flow of traffic. So currently, Uber Air is claiming to be investing in a suite of software that includes an unmanned traffic service or a UTM service. At this stage, there's little information on what that service looks like. So taking a step back and looking at what an air traffic management service looks like today for manned aviation, currently pilots file flight plans before their flights. And these flight plans include information like departure times, arrival times, cruising altitude, speed, the list goes on. And there's an existing format for these plans. There's a certain level of uncertainty with each flight, and the flight plans that are filed provide a general overview of the intended flight path and other parameters, but they can't account for unforeseen events and potential delays, especially for long-haul flights that are filing these flight plans more than 10 hours out from their destination. So what's the relevance of this to unmanned aircraft? One is the data collection aspect. Flight plans are a good source of data for intended flights. It gives a good indication of anticipated operational activity. So this helps to an extent with organising aircraft for departure and arrival and during cruise. Translating this over to unmanned aircraft, flight plans can carry the same purpose, but perhaps be delivered in a more autonomous way. It's essentially planning and announcing flight intentions. So if an unmanned traffic management system is going to be autonomous, this pre-prepared information will be crucial for safe flow management. I will note though that while there is an existing format for current flight plans, I think that this format will have to be changed to fit the needs of unmanned aircraft and to provide relevant data for an unmanned traffic service. This data set may potentially look quite different for unmanned services in comparison to the data set for regular passenger transport. Also, flight plans they're not a definitive plan. So aircraft can and will divert away from this plan for many reasons. including avoiding bad weather or avoiding a potential conflict. So this needs to be considered with unmanned services. If an unmanned traffic management service, it needs to be a dynamic service that can respond to changes from the initial data set and also cater to unexpected events or changes. Another point of relevance in communication, as I've mentioned, manned aviation is built on a system of communication. It's a really critical component to achieving efficient and effective airspace use. So it's important to look at how we translate that communication into unmanned systems. Again, this can potentially be delivered in a more autonomous way, depending on how autonomous the systems are. And so this goes back to the earlier point that I made, emphasizing the importance of identifying levels of autonomy. It's really difficult to build a system around a big question mark on the level of human involvement and decision making. I think that there are core principles from manned aviation that need to be reflected in an unmanned traffic service. An obvious example is right of way for emergency vehicles. It's the same with cars. It's pretty standard and straightforward. But what is potentially less straightforward is how that's achieved. A really big question mark at this stage is how manned and unmanned aviation will operate together in the same airspace. There's little indication on how that will work. I think that there's a need for a common communication interface between unmanned and unmanned aircraft and unmanned and manned aircraft. We need to establish how these systems will communicate with each other. What medium are they communicating through? What form is the data in? There needs to be some level of software compatibility to ensure communication between these systems. The final area I wanted to touch on was regulations and standards. Because the unmanned transport industry is surpassing regulations, these autonomous systems will be brought to market well before an effective regulatory system is in place. When considering regulating drones, I think that it should be considered in a few parts. There are the obvious rules of the air and airspace classes that I've spoken briefly about, but one of the most critical components that needs standardization and regulation are the software systems. I want to emphasize at this point that the software systems and the operational applications of the vehicle are not the same. It's important to separate the aviation aspect from the software system. They're two quite distinctly different things. Aviation standards around operational practices, rules of the air, etc., they don't cover software systems. The regulatory framework needed for these systems will be vastly different from what's currently in place for civil aviation on a general sense. So, for example, most aviation standards don't change very much over time, but software systems are quite the opposite. Software is amorphous and it's dynamic. Updates and changes are a constant with most systems. So testing and evaluation will look very different. Static testing may not be a possibility. So how do we test and validate and verify that these constantly changing systems, how do we test and validate and verify these constantly changing systems at the same rate that they're changing? Currently, there's no global standard around software development. There are some ISO and IEEE standards around testing and validation, but these standards, they don't cover all applications. There also exists things such as formal verification and static analysis to verify that code is safe. While these methods are good, they're not exhaustive and they do have a long way to go. But still, there's no global software regulatory framework. Simply put, a global software framework is not feasible. Software development is an enormously diverse field that ranges in scale from mobile apps to automated transport. So it's almost impossible to develop an overarching regulatory framework that encompasses software systems on a global scale. There are a number of logistical issues that we'd face, things like how do we enforce it? So how do we stop people from releasing software that hasn't met a set standard or isn't properly verified, considering that software can be developed and released by anyone, anywhere? How do we verify that standards have been met? Who is verifying or auditing these software systems? And, I'll note here at this point that because software is so vast in its application, auditors will most likely have little to no understanding of the context or application of the developed software that they're auditing. Another logistical issue, who's representing this body? Who manages it? Is it government? Is it industry? Who is developing the standards? Those are just I think, a number of the issues and limitations around a global framework. And I think a really important discussion that needs to be had is, are the current aviation regulators the correct body to be regulating the software systems of unmanned aircraft? Again, I want to emphasize at this point that I'm referring specifically to the software system and not the rules of the air. I think that the software systems will need to be regulated by a consortium of companies and universities and government bodies that all have a stake in the game. They all have an interest in these systems and can work together to build a regulatory framework. They'll all need to contribute time and acknowledgement to the development of standards. And to ensure fairness, I do think that the body would need to be chaired independently. I think a few people would probably question, why would companies or universities invest their time and knowledge into this framework? Regulatory frameworks, they dictate the limitations of an industry, the rules, the boundaries, the complexities. So if you're anyone who works or contributes to the field of unmanned aviation, you'll want to say, you want some influence into the developed standards. Also, the companies developing these systems and the universities that are doing research into them, they're the most qualified people to be developing the standards because they have the greatest amount of insight into these systems, into how they work, into what their limitations are, what their needs are. I wanted to now just take a second to share an example that highlights the importance of software systems behind different applications and how much influence and impact they have over things going wrong. So in Canada in the 1980s, there was a computer-controlled radiation therapy machine called the Thirac 25. This machine had two modes. One was an electron beam therapy mode and the other was an X-ray mode. The machine actually resulted in the deaths of 6 people because these patients received massive overdoses of radiation because of programming errors. After an investigation, software failure in 2 parts was deemed the cause of the accident, and these failures were a result of human error when using the system. A woman named Nancy Leifson from MIT wrote a paper on this, and in her paper, she investigates the incident and the software failures. And she goes into quite a lot of depth into the tasks and subroutines in the code that are to blame for the accidents, which is essentially a software flaw that wasn't picked up until the incident occurred. She points out a number of lessons that can be learned from the accident that I think are really relevant to this discussion. So I wanted to touch on 5 of those lessons today. The first one is overconfidence in software. A lack of understanding of software can and has led to people assuming that software cannot or simply will not fail, which leads to complacency and over-reliance on computer functions. This ties in with one of my earlier points that we need to separate the software component from the aviation component. We need to have a dedicated regulatory framework around the software component, and this framework needs to be developed by people who have a deep knowledge of the software. There's a difference between regulating the application versus regulating the development. Confusing reliability with safety. Reliability and safety are not the same. And I think this goes back to sort of the terminology that I touched on in the beginning and constant misuse or using words interchangeably. Safety is about risk and reliability is about dependability. So just because a system operates in the same way every time, it does not mean that the system is safe. Another one that I'll add here is quality assurance. Quality assurance looks at compliance with requirements, not risk. So having achieved or satisfied the requirements for quality assurance does not mean that the system is safe. Lack of defensive design. This is really about ensuring a system has a means of self-checking or detecting errors and including features to handle those errors. So with current manned flight, we rely on pilots to handle those errors. We rely on them to be able to understand, interpret, and act on any errors that come up. But how do we translate that to unmanned aircraft? Failure to eliminate the root cause. So virtually all complex software can be made to behave in unexpected ways under specific conditions. There will always be another bug in the software that needs to be fixed. And so because of that, software should not be the single point of failure. Protection against software errors should be built into the system and the hardware to better protect against them. And the final one that I wanted to touch on, which I think is really, really important, is inadequate software engineering practices. This refers to complacency in areas like software testing and documentation, quality assurance, error detections, and the list goes on. This is heightened with the lack of existing standards and procedures. As I mentioned earlier, there are some standards around testing and validation, but there's a long way to go. When bringing unmanned aircraft to market, we need to have some level of assurance that these systems have met an acceptable standard of safety, and that that acceptable standard has been developed by people who actually understand what safety requirements are for autonomous software systems. I think those 5 lessons that Nancy identifies are all relevant to the unmanned aircraft space. These are elements that we need to consider if we want to bring this industry safely to scale. I think that when we talk about drone safety, how code the safe is not a discussion I hear very often. We talk a lot about different and important things like conflict avoidance, noise abatement, and other things, but rarely do I hear discussions about the safety of the developed software. And I think a lot of it has to do with not being able to separate the aviation component from the software component. This is why I question whether current aviation regulators will be capable of regulating software. It's a different field, it's a different school of expertise, and even the culture around software is drastically different to the aviation culture. So I just think it's important that we start having discussions around the different components that make up the system. Thanks everyone, that's all from me. Happy to take any questions.
Oh, thank you so much, Zena. I need to first confess that you have really hurt my head in a good way, but this is definitely out of my expertise. So I'm going to invite people who are on the Q&A and on the line to ask any questions, because I actually have so many, but they're all really probably very simple ones, so forgive me. We had Justine start the week from Cyro, and her whole thing was really about, when you're on the bleeding edge, which you obviously are, is when you ask these questions and sort of question, how does this work? What could go wrong? How are we doing this responsibly? Are you seen as a brake on innovation? I mean, is regulation going to be seen a brake on what's possible? And in your work, when people sort of stop and you ask these questions, is it welcomed?
That's a really good question. I think a lot of people, it depends on what side of the area you're on, I guess. So if you're on the industry side where you're trying to bring things to market and to scale and you want to make money, regulations aren't your best friend. But then when you're on the regulation side, it's also really hard because it's hard to properly regulate something if you don't have a deep understanding of it. And this is one of the points that I made. So I think regulation has sort of a legacy culture behind it. And a lot of the times, and I think Amber touched on this as well, a lot of the times changes don't happen until something bad happens. We make changes in response to a problem as opposed to in anticipation of one. And so because of that, it's really hard to be on both sides. It's hard to be the regulator and enforcing standards and regulations in a field that you don't have a deep understanding of. And then it's hard to be on the industry side and have to abide by these regulations that do limit you in some ways, which is why I feel like for unmanned aviation and these autonomous software systems, it should be similar to the internet. It should be regulated by a consortium of people from different backgrounds who have a different stake in the game, who have different interests and different things to gain. And because of that, you would have, I anticipate, a much more thorough and effective regulatory system as opposed to a conservative and constricting regulatory system. You want the system to be there. You want people to meet standards. You want to know that they're checking that their code is safe, that they're doing testing, they're doing validation, they're doing verification. But how do you know people are doing that unless you set a standard that they have to meet? So it's a difficult conversation to have that not everyone likes to have. And the reaction it differs depending on where you sit, whether you're on the industry side or you're on the regulatory side.
Yeah, but isn't regulation is always playing catch up? And as you said, unless people understand what's possible. I mean, when you're talking, I suppose, delivery of, you know, a jumper or something, there's not much that can go wrong. But Alan, your colleague, Alan Broad, was talking yesterday about how drones, for instance, might be used in this COVID period to help with social distancing. You know, and I don't know, what do they do? Smack you out of the way if you're too close to someone? I don't know how it works, but I mean, what worries you about some of I mean, what's possible? Because I don't even know what the plan is for autonomous airborne vehicles. I mean, what could they do? Like, what's the thing that keeps you up at night that they could actually do if, what did you say, there's an overconfidence in software? Like, what are some of the what are some of the mistakes that we could see in our airspace?
For me, my biggest concern is I don't have a deep understanding of how these systems will communicate with each other. So as I said, Uber Air they're claiming that they're investing in this suite of software, but that's a suite of software that they're investing in, and they're not going to be the only player in the game. So if you've got Uber Air's suite of software that exists, and then you've got all these other companies that have all these different softwares that they've invested in, I don't understand how they all communicate with each other. And if they're all working on a different logic trail, how do you know what the decision-making process will be for each one? Air traffic management and air traffic control is an incredibly complex system, and I struggle to understand how that will translate to unmanned aircraft when there is no common communication interface. So that is my biggest concern.
Wow. Yes. So is there much communication, I suppose, with, you know, on land autonomous vehicles? Are we seeing any, have you found that there's any parallels there?
Not really. So with the on-land autonomous vehicles, it's heavily reliant on sensors. And it's the same for autonomous aircraft. They do have their sensors that they rely on. But I guess the difference with an autonomous vehicle on land is that it is on land. Like when you've got one in the air, it will just fall out of the sky. The repercussions they're quite enormous. So with the autonomous vehicles on land, if you've got a driver in the seat, you can always override and control the vehicle. Whereas when you're looking at a drone delivery service where there is no pilot there, you don't know if it's being remotely piloted. And this sort of goes back to the levels of autonomy that I was talking about. To me, there's quite a big question mark around the levels of autonomy for these aircraft. I don't know, are they remotely piloted? Is there someone who can override and come in and take over and make a decision if they see that some kind of catastrophic event is going to occur? I don't know.
So are you finding that in your work, I mean, is this your actual prime focus? Is this what you do every day?
No, it's not. It's one of my areas of research. So I have a background in aerospace engineering, and I did a PhD in strategic air traffic flow management. So air traffic flow management and unmanned traffic management is an area of research interest for me, but it's not what I do every day.
And what are you currently working on?
So I work at the 3A Institute, and we deliver a Masters of Cybernetics. So that currently takes up quite a bit of my time. And then we also have some additional research projects that we do on the side. One research project I am working on is autonomous underwater vehicles. So that one's been a really interesting project to work on.
And is there parallels? I mean, going into another sphere here, because you've got, I suppose for me, it is expanding my head somewhat. You know, in terms of water, I mean, there must be some things, and what is going to happen in that space as well? Like, can you see some of the dangers or some of the things that you're talking about in terms of reliance on software and assuming that there is going to be, you know, the same sort of things are going to come up there as challenges or not?
Yeah, definitely. You know, with autonomous underwater vehicles, one of the issues that you have is marine life and the safety to marine life. Another really big one is recovering these vehicles. So if something goes wrong, if they get swept up with the current, they smack into something goes wrong, how do you recover these vehicles? It's essentially trash sitting in the ocean if you don't recover it, which is not the best thing for our marine life. They also have a lot of issues with currently the technology is not advanced enough for these vehicles to be able to withstand different conditions underwater, which means that they do get swept away with the current and things like that. So yeah, the underwater unmanned vehicle field is also just as complex.
Will Webster, thank you for chiming in here, because he's got a question for you, Zena. How can open source systems best be regulated, and who is responsible for the issues uncovered? Are we moving in that direction, do you think?
Well, one of the points, thank you, it's actually a great question, but one of the points I made in my presentation is there is no global software regulatory body, and I don't think that there can be one. I think that the global software area is too vast. So as you're talking about with open source products, how do we regulate that? First of all, the application. So open source products can literally be for any field, for any application. Anyone can develop it, anyone can release it. Where would you even start with that kind of regulation and that kind of standard? And to the question of who makes up that body and who regulates it, again, where do you start? Like, if you're looking at one global regulatory body to regulate software as a whole, it's so vast and so diverse that I just don't think it's feasible to have one global body for software as a whole, which is why I think that we need pockets of regulatory bodies for different industries.
So are you telling me that Uber's software service, like once it's sort of delivering, and something like Amazon don't have any shared sort of communications at this point?
Not that I'm aware of. Maybe they do behind the scenes and they're working on something fantastic. But from the research that I've done and what I've read, I'm unaware of a common communication interface that is being developed for autonomous vehicles.
Be very frightened.
Yes. Well, they're claiming that these vehicles are going to come to market by 2023. So
I know. And I suppose this is one of the things we wanted to sort of cover with responsible tech, because we sometimes see, responsible AI and, lots of different things coming up. But, it is across anything we're doing in tech, which is why we wanted to sort of, make this huge umbrella. And I suppose for many of us, it's, not today, even tomorrow. Some of it, we think of as light years away. But we also know that future is, coming at us pretty fast, and regulation, in 3 years
apparently.
Yeah, exactly. And regulation isn't really going to help. I mean, what about the whole idea of self-regulation? Have you seen any examples of people sort of saying, this is what I'm doing? I mean, that's how some of the internet went. This is how I'm doing it. I'll share with you what I'm doing so you can plug in as well. Are we going to start seeing some of that happening, do you think? Good.
I think self-regulation. I think self-regulation is already a thing for some software engineers. So when software engineers do their degree, at least for here in Australia, I'm not sure about the rest of the world, they do have systems engineering practices and testing and validation practices. And so when these software engineers go into their careers, it's just, I guess, it's on them and the level of integrity that they take with their job of how much they choose to keep up with testing and documentation with the projects that they work on. So I guess that is sort of a form of self-regulation. It's something that is taught in Australian universities, how to properly document your code, how to test your code, how to check it's safe. But whether or not people actually do that, it depends. I guess it depends on a lot of things. It could depend on the culture of the workplace that you're in. Maybe they just want things produced really fast and they're like, oh, don't worry about the documentation. We'll get to it later. Let's just get this out. Maybe you work in a different workplace where that's, actually really pushed and people are like, no, we have to have this documentation. And I think this goes back to why it's really hard to have these global standards, because software is just so diverse and it's embedded in almost every industry. So where do you even start? All these industries have their own cultures and their ways of doing things, and it's really hard to try and combine that all into one.
Yeah, I suppose it goes back to what Amber was saying though earlier, Zena, that, all of these techies could be fantastic at what they do, but without, insights from other people, are they considering the seagull? Are they considering the, there's so many factors that wouldn't be in their experience. And I suppose, these are the challenges. I want to thank you so much for opening up my brain to an area that, I didn't know much about at all. So thank you so much. And I've got the opportunity, of course, to watch it all again and really try to take it in. So thank you so much for being part.
Thank you for having me.
Yeah. And we're hoping, with responsible tech in the future, I think what doing at ANU is so interesting. So we're hoping that we will showcase some of the projects going forward, because I think lots of people are interested in hearing about where we're going and what's possible and what we need to think about. So thank you so much for enlightening us. We'll be back at 11:30 with Phil and Tony. Join with me in thanking Zena. Thanks so much, Zena.
Thank you so much.